Good morning, geometry students. I hope we're ready to get going here on the review. I received some feedback that the idea of the keywords is a good idea, and so I included them in this review, but I'm going to make it kind of a little bit even better for you. I'm not including it in the submission form you'll do today. However, I will let you put those keywords on your quiz for 1 bonus point each, and there are 5 of them. So keep yourself paying attention. Hopefully that'll keep you focused. Thanks for that feedback that let me know that it helps, because I'm all about trying to find things that are going to help you stay interested. So keep an eye out for those keywords and then keep them handy for when you take your quiz so you can write them down, okay? All right, so let's get on with this review and think about figures like this. Now, figures like this can be turned any which way. They can be on their side, they can be flipped over. The key thing is that you've got parallel lines here, and then that divides the sides up into proportional pieces. However, we also have to keep in mind, because we have parallel lines, we also have similar triangles. So both of those things come into play here, so we want to make sure that we remember that when we answer questions such as this. I'm going to transition over to this type of a thing. Okay, so let's answer some questions about this. This is a great figure because there's lots of things happening in it. If we have these numbers put in, we can actually do some solving of problems. But first thing we need to do is be able to identify the parts that actually make proportions. QU goes with UT, like QR goes with, and we remember we thought of it as a fraction bar, so this part down here would be RS. Okay? ST goes with RU. Wait a minute, that doesn't have anything to do with the sides. No, it doesn't. So think about the similar triangles here. So ST and RU are sides of the two different triangles, the big triangle and the little triangle. ST goes with RU, like, and our bottom part is QU, so you want to find the side that's like QU in the big triangle, so that would be TQ or QT. Okay, so like that. So don't forget about the similar triangles. Same picture, we can do other things. Remember I said that this picture can get turned any which way that we want it to, so we can look at a lot of things here. Let's give ourselves a little more room. There we go. Okay, so I want to find UR. Okay, I want to find UR. So we already know that there is some things happening as far as proportions on this. We have a small triangle and we have a big triangle that we can deal with here. We don't have enough numbers on this side to actually use the QT as our long side. However, what we do have when we're trying to find UR, okay, what we can do is we can think in terms of the proportional triangles here. And we can look and we can see that UR on the small triangle, we're going to call that X. Okay, X is in the same position on the small triangle as 6 is in the big triangle. So then we're left to find things that have numbers that we can make into these proportions. So UR on the small triangle is in this end. If we look at 9 on the small triangle and then figure out what's in the same position as 9 in the big triangle, and we get this whole long side here, which is 13. So you can then cross multiply 13x equals 6 times 9, 54. And then we can just do a quick division problem on that one. Okay, so we have 54 divided by 13. And it's not going to come out to be a whole number. We can just round to the hundredths, 4.15. So we'll just say it's about 4.15. So UR is about 4.15. Okay, how about UT? All right, this one's a little bit more easy to see because you've got the fractions that kind of pop out at you. You've got 9 goes with 4, like 8 goes with, and we'll just give this another variable. Let's just call it y, as 8 goes with y. 9 goes with 4, like 8 goes with y. You're not even thinking about the proportional triangles. You're thinking about the proportional sides, which is much easier. But if you end up with these parallel ones, make sure you think it through a little more carefully. 9y equals 32. Divide by 9 on both sides. So 32 divided by 9. Once again, I'll let you go ahead and do decimal approximation, 3.56. So it's about equal to 3.56. Notice that I am putting variables right in the picture. Redrawing the picture or having the picture, if you have a way to print it out, is very, very helpful to you. All right, so then we want to find out how much QT is. Okay, so QT, let's make this one into, we can just make it whatever we want. Let's just make it into a C for some lack of something better. So that we have this, we can set up a proportion here in any way that we want. You can also use the idea that you also already found y. That's helpful. So I could simply, if I wanted to, take 8 plus y, and that would be 11.56. Okay, so don't forget that you can do stuff like that. If you wanted to also, you could do proportions. Okay, and you could do something like C in the big triangle goes with 8 in the little triangle. C in the big triangle goes with 8 in the little triangle, like 13 in the big triangle goes with 9 in the little triangle. So you could do that way if you wanted to. We would have 9C equals whatever we get, 13 times 8. 104. And then 104 divided by 9. If I did it right, we should get the same answer. Yep, 11.56. So you can either do by proportions, thinking about big triangles and little triangles, or you can do it by, okay, I know 2 pieces, I can add them up. Either way, you should end up with the same answer if you're doing everything right. So a couple different ways to handle stuff like that. All right, now, speaking of proportional, that's your first keyword, proportional. Proportional works for perimeters, and I noticed on some of your sheets, actually quite a few, there was a little confusion about whether proportions with perimeters got squared. In perimeter does not have a square attached to it at all. It's only the areas that end up with a square attached to it. Perimeters are just plain proportional, which means no squaring at all. So please write that down, because there were quite a lot of you that thought that you had to square when you deal with a proportion, and you don't. Okay, so these are similar. So that means that LM 12, that goes with this, over 8, flat out proportion. LM AB is 8. So this one goes with this one. Like the perimeter of LMO, which is 50. This one came from LMO, this one comes from LMO. And then our perimeter of ABC is our unknown. So you can either reduce and then cross multiply, or you can just cross multiply here real quick. We get 12p equals 50 times 8, 400, and then divide by 12. Divide it by 12. And get 33.3 repeating, or 33 and a third. So it's about equal to 33 and a third on that. So this is just straight out proportional. Once again, first key word. Area, though, is different. Area, you still think about the original proportion. Okay, so we still have this. We still have the 12 over 8. But the idea on this one, when you're finding the area, is that you do need to square. Okay, for areas, you do need to square. So it's much more convenient in this case to reduce your fraction. Divide by 4, divide by 4, because your original proportion, okay, 3 over 2, that 3 over 2 is proportional, the square of that. So it's the square of your original proportion equals the ratio of the areas squared. So the area of triangle ABC, okay, remember we have something from LM over AB, something from ABC. So that means that something from ABC has to go in the denominator. And our area of LMO has to go in the numerator. Watch that. Be careful of that. Here we had LM over ABC, LMO over ABC, LMO over ABC, LMO, which is what we're looking for, over ABC. But don't forget to square it because of the word area. So this means area over 28 equals 9/4. Cross multiply. So 4a equals 28 times 9, 252. And then divide by 4. You divide both sides by 4. And we get 63. So my area is 63 square units. Okay, so we have that. So be careful of those things. Moving right along. Okay, here's our second keyword, the second keyword being subtract. Subtraction is sometimes important. Okay, so for example, if we have parallel lines here, and this once again can get turned on its side or whatever, but you've got parallel lines here, and we have the idea of proportions happen here. Okay, so in other words, this piece over this piece equals this piece over this piece. Looks like it's almost impossible because you've got that extra variable, but it really isn't. Okay, so here we have x, and you may have to fill in some of those things. Remember, fill in, draw pictures to help yourself. But 35 is this whole one. This piece is 35 minus x. Okay? So that's your key thing there, is to subtract. So these fractions equal each other. 35 minus x over x equals 3a over 2a. Wait, but there's too many variables. Not really, because look at this. A over a cancels out. So this is really 35 minus x over x equals 3 over 2. Don't let those extra a's bother you, because then you can just cross multiply. X times 3 is 3x. This one is 2 times 35 minus x. So this would be 70 minus 2x equals 3x. Add 2x to both sides. Get 5x. Divide by 5. 70 divided by 5, that gives you 14. So your answer there when it says to find x is 14. Okay, let's move it right along. Okay, we did that one, we did that one, we did that one. And we are now set to do these. Okay, here we have the ideas where you've got the bisector, and remember the bisector, the angle bisector divides it up into proportional pieces that go like this. Okay, so once again, proportional pieces, 10 goes with x like 9 goes with whatever this is. This is another one where you need to subtract because 18 is the whole piece here. So this one right here, this part right here, is 18 minus x. This side, 18 minus x. So what you need to do is you set it up as 10 over x equals 9 over 18 minus x. So we'll cross multiply. We get 9x this way. This way we get 10 times 18 minus x. So 180 minus 10x equals 9x. We will add 10x to both sides. And that gives you 19x. So x is going to be about equal to 180 divided by 19. So about 9.47. So there's our answer there. On here, if we want to find BC, we have a couple things going on. First of all, you've got a right triangle. Second of all, you've got this whole divided up into equal pieces here. So I want to find BC. I'm going to label it X. So some of these you do have to put your own labels in so that you can find X. So I'm going to be trying to go with 5 over X equals 12 over something, but I don't know what that something is until I find this hypotenuse of a right triangle. A squared plus b squared equals c squared. Pythagorean theorem is your friend. So 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. C squared equals 169. C equals 13. So this is 13. So if 13 is the whole piece, then once again we can subtract, and this will be 13 minus x. We need that so we can set up a proportion. 5 over x equals 12 over 13 minus x. Then we can cross multiply. So we have 12x across this way. 5 times 13 minus x. Sorry about that. 5 times 13 is 65 minus 5x equals 12x. Add 5x to both sides to get 17x equals 65. So x is about equal to 65 divided by 17. About 3.82. Okay. Okay, good. So moving right along. Okay, we are back to, let me see here, get rid of this one. Nope, that's not what I wanted. Back to here. Then we got to circles, okay? And in circles, our keyword is multiply. You're not finding proportions in them. Both of these cases, you've got some multiplication to do, because this one times this one equals this one times this one. If it crisscrosses in the middle, you've got the easiest work to do of all. And our directions here are to find x. Okay, over here the directions are find BC, but let's find x first. Third keyword, once again, is multiply. So this one, as I said, one of the easiest things you're going to do, because all we have to do here is take 3 times 10 equals 4 times x. Okay, so this would be 30 equals 4x. If we divide both sides by 4, we get 7.5. Okay, so multiply. This one also involves multiplying, but there's a little bit more to it. So we need to fill in our things that we need to and make our own x. So we're supposed to be finding BC. I want this to be x. I want AC, it says this whole thing all the way across here, and notice I do take the time to label it, is 18. CE, this whole thing across here equals 20, and CD equals 12. Now if you remember how the multiplying goes, it has to be this times the whole thing. This times the whole thing. It's not just this piece in here. So for this one, we have 12 times 20, sure, equals 18 times x. Okay, like that. So if we're going to find BC, 12 times 20, (240) equals 18x. And those of you that are quick can figure that out. 240 divided by 18. 13.3. Repeating 13 1/3, or 13.33. Okay, any of those things. Okay. Okay, on a problem like this, we've got the same concepts. You just have to watch and be careful what you have and what you're trying to find. So let's go ahead and do this. AC, it says in this case, is 36. So we've got this whole long one is 36. AB, it says, is 20. CE, the whole long thing here, is 32. And we're supposed to be finding CD. Okay, now the problem is that we're supposed to be multiplying this near one times the whole thing. The problem is that we're not given it, but it's a simple matter of finding this missing piece, because you have to take 20 minus 36, because 36 is the whole thing, and together they have to make 36. So I have 16. You just have to figure out what you're multiplying. So what I'm multiplying, I'm taking 16 times 36 is going to equal 32 times x. Just be careful of how you're multiplying that out. So 16 times 36, 576, equals 32x. Divide both sides by 32. Equals 18. So in this case, a nice whole number, and x equals 18. And so that's how that would all work and play out. And here we are with the next one. It all looks the same. It all has that multiplying, but this one comes out a little bit different. So you're watching what you need here. So 82 right here. DE is 60. Okay, lots of things happening in this one. CB being 48. And we're supposed to be finding AB. Now be careful on this one, because remember, it's the long piece multiplying that gives you. So first thing you need to do is you need to put these things together. So you have the things that you can multiply in order to find the missing pieces. It's not just a simple fraction. It's not a proportion or anything like that. So this is 142. when you add them. This one, when you add them up, is x plus 48. So that when you're multiplying, you're taking 48 times x plus 48 equals 82 times 142. Okay, so a little bit more to do this. This is 48x plus whatever 48 squared is. Let's see, 48, 2304. And over here, 82 times 142. Never let big numbers intimidate you, okay? 11,644. Then we need to take away 2304. So 48x equals minus 2304. 9,340. Then divide by 48. And 194.58. Okay, so those are those. Okay, I know I kind of camped on them for a while, but just to make sure. And one more of these things, our keyword here, fourth keyword, and I think I skipped one. I skipped multiply. Multiply was supposed to be a keyword. Your third one is multiply. And this fourth one is square. So your 4 keywords, just in case you missed them. So far, proportional was the first one, subtract was the second one, multiply was the third one, and the fourth one is square. Okay, so fourth keyword is square, because when you're looking at this outer one, we want to find both x and c in this case. And we're trying to find x, it's the square of this product. And when we are trying to find c, it's like the things that we were just doing a minute ago. So let's start off with finding x. Okay, so when we do that, because this is a tangent line, it's not a secant, we have a little bit different. So we're taking x squared equals 10 times 25. Okay, 10, and then you can get this together. We can ignore this one. You don't have to bring everything into play, but our tangent is like this. So x squared equals 250. So then when we square root 250, and I'll let you do an approximately equal to on this one. So 250, and we can do our square root. 15.81. Okay, so there's our x. And our c, once again, you have to take the 12 and the 12 plus c. So 12 times 12 plus c equals 10 times 25. So I have 250 equals 144 plus 12c. Subtract 144 from both sides. 12c equals, let's do 250 minus 144, 106 divided by 12. So 8.83, about 8.83. I think on your quiz it comes out with more whole numbers, but if you can do the decimal approximations, or when you get a whole number, just be happier. Okay, and then finally, our last keyword is a cube. So our fifth keyword is a cube. And so we have a box that has a volume. Now here, when we have a cube that we're dealing with, or cubic units, our volumes equals the proportions cubed. Okay, so our dimensions 1/3 the measure of the original box. So in other words, you have a length and a width and a height. So what we can do here is we say that we have the volume of the original, okay, is 822. The volume of the new one is what we're trying to find. Okay, the width of the original, we're producing a smaller box so that the width of the new one is 1/3 of the width of the original box. So I like to think about it more the other way, that the width of the old one is 3 times as big as the width of the new one. It just makes it easier. You don't have as many fractions to deal with. So you multiply both sides by 3 in order to get the width of the original equals 3 times the width of the new one. So our volume of the original compared to the volume of the new equals the width of the original divided by the width of the new cubed. Well, how is that going to help us? Because we have some things we can plug in here. Okay, so I have my volume of my original is 822 over the volume of the new one. My width of my original is 3 times the width of the new. Well, why do I want to put it in terms of that? Because I'm going to be able to do some nice canceling out here. And the width of the new we're going to leave as the width of the new to the 3rd power. If you want and you don't like to have these variables, you can pick some random number to be the width and it will still work out. Okay, so 822 over the volume of the new one equals, the 3's cancel out so that I have 3 over 1. 3 cubed is 27 over 1. Then you can cross multiply. 822 equals 27 of the volume of the new, and then divide both sides by 27. And when you divide both sides by 27, 822 divided by 27, we're going to get 30.44. So the volume of the new one is approximately equal to 30.44. Okay, so this one does have to deal with cubes. I have one more that deals with cubes. Cube has an edge length of e, so remember it's just e to the 3rd power, okay, and the new cube with an edge of 4e, length of 4e. This one actually is a little bit easier. What is the volume of the new one in terms? So we've got the volume of the old one compared with the volume of the new one equals, a cube has a length, volume, an edge length of e. The old one is e, the new one is 4e. But because it's a volume problem, it's cubed. Now the volume of the old one is v, so we don't even need this subscript. The volume of the original one is v. We want to know the volume of the new one in terms of v. So what we're doing here, we can cancel out these e's again. 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. I have v over vn. Well, how in the world does that help me? because they want the volume of the new cube in terms of V. So if we cross multiply, we have the volume of the new one equals 64V. So your answer here is 64V. There we go. Now, if those last two problems confused you, okay, let's think this through. Try your best, okay? With the value of the questions, even if you use all of your keywords, okay, if you wrote down the keywords, and that's an easy 5 points for everybody. If you wrote down the keywords and you got both of these questions wrong, you could still get 100. Okay? So I'm trying to be as fair as possible, but also giving you an opportunity to excel. Okay? So with that, Jesus, please help everybody do a really good job on this quiz. Bless us. Thank you for what you've given us today. Encourage everyone. Help us to learn a lot, and pray for each student to you give them peace, help them to get ready for a great summer, and thank you that we are heading for that and we're almost done our school year. In Jesus' name, amen.